In this question, we have a third degree equation. In other words, your highest exponent is x to the power of 3, or then just 3. That's the highest exponent, which means you cannot just factorize. You need to follow a different route altogether to solve for x in such an equation. And in this specific memorandum, we use the remainder theorem to find one of the three factors of that equation, and then use algebraic long division to find the other two. So it's a very simple process. You just need to know how to apply the different techniques, starting with the remainder theorem, or then actually the factor theorem. The factor theorem is just the remainder theorem with a factor or a remainder of 0, and then long division or synthetic division, whichever you prefer. I normally use long division because it gives me a 0 right at the end, which is a confirmation that the original choice of a factor was right. But it's not necessarily the only technique that you can use. And then you've got three brackets, which then looks familiar because normally with quadratic equations you end up with two brackets. And then you take each bracket individually, make them equal to 0, and you solve for x, and there you've got the three answers, or the three roots for the equation. The important thing about this equation that you need to see is the fact that you've got a highest exponent of 3, which means your normal techniques of factorization, which you will use in quadratic equations, is not going to apply. We need a different technique altogether. The second most important thing is the fact that there must be a 0. Like with quadratic equations, you also need a 0 on the right hand side for higher order equations, so that you can factorize the left hand side. In this case, we're not going to use quadratic factorization, but we are still going to factorize. You are still going to get three brackets on the left hand side equal to 0, and then you can take those brackets individually, the expression inside the bracket, and make them equal to 0, so that you can solve for x, ultimately then getting the three answers, at the most three answers for your equation, solving for x. But the important thing is to look at a technique to solve this which is not quadratic factorization, and a good technique that can be used is the remainder theorem. So what you literally do with the remainder theorem is you pick a few possible factors, like x plus 1 or x minus 3 or something like that. You play through them until you find the one that gives you a remainder of 0. So then you've got one of those brackets, which could be, for instance, x plus 1. Once you've got that, you then use long division or synthetic division or whatever other technique you prefer to find the answer of the division. So you divide that by whatever factor you've chosen, using, for instance, algebraic long division. I prefer long division because it confirms the 0 remainder for me at the end. But that answer, the quotient of that division, will then be factorized, because in this case it will be a quadratic equation, which will then give you those two brackets, or maybe just one. It depends on whether it can be factorized or not. Does it have real roots or not? But let's assume it does. You end up with three brackets after going through the remainder theorem, after going through a division process. And once you get to those three brackets, you just make them equal to 0 individually, and you've solved your question.